let's talk about binary compounds, particularly ionic binary compounds. They consist of only two elements, and for ionic compounds, they're named by giving the name of the metal ion, followed by the name of the anion, where the anion uses a suffix of IDE. And we include the charge of the metal ion written as a Roman numeral in parentheses. The exceptions to this are those metals that have only one possible charge, such as the alkali metals that are always +1 and the alkaline earth metals that are always +2. So examples are NiBr2, which is nickel bromide. Bromine is in group 7, it's -1. Got two of those, that means each nickel must be +2. As opposed to nickel 4 bromide, where each bromine is -1, 4 times a -1 is a -4, that means each nickel must be a +4, and hence nickel 4 bromide versus nickel 2 bromide. NaCl, table salt, is simply sodium chloride. Mn2O3 is manganese 3 oxide. Now, how do we get that? Oxygen is in group 6A, so it always gets a -2 charge, and we know manganese is a D block metal, so it can have various charges. So 3 times -2 is -6. We've got 2 manganese that all have to add up to +6. That means each manganese is +3. So hence we name this as manganese 3 oxide. And the sum of the charges always has to equal 0 when we're talking about ionic compounds. So let's do the first two examples. They're both iron bromides. Iron bromide and iron bromide. But they have different chemical and physical properties, so they have to have different names. And so we do that by telling the charge on the metal ion. Bromine, as we noted up above, is a halogen. It's -1. We've got 2 of those, so the iron must be +2 here. So this becomes iron 2 bromide. Compared with the next problem, iron FeBr3, we've got 3 bromines, each worth -1. That all adds up to -3. That means my iron has to be +3 to balance it out. So this becomes iron 3 bromide. Iron 2 bromide, iron 3 bromide. Next one is barium, which is +2 always, because it's in group 2A, and oxygen is -2. And so this is just simply barium oxide. You could say barium 2 oxide, where 2 is in parentheses, but chemists like to be efficient, and since barium only has a +2 charge, we can leave that out. Same is true of magnesium chloride. Chlorine is in group 7A. When it becomes ion, it becomes chloride, each with a -1 charge. We've got 2 of those. That means magnesium has to be a +2 charge. And we would know that anyway, because if we look at the periodic table, magnesium's an alkali earth metal. Group 2 always gets a +2 charge. Now we've got 2 iron oxides. Iron oxide and iron oxide. We have to tell the charge on the iron in each of these. The first one, FeO, oxygen in group 6A, it's got a -2 charge. To be electrically neutral, this iron must be +2. Iron 2 oxide. Even though there's not a 2 anywhere in the formula, FeO, we name it iron 2 oxide. The next one, Fe2O3, each oxygen is worth -2. 3 times -2 is -6. That means to be electrically neutral, all the irons have to add up to +6. We've got 2 iron, so what is each iron? It's +3. So this becomes iron 3 oxide. Now we got 3 chromium oxides to look at. Trio of chromium oxides. They all have chromium, just Cr, and oxygen, which becomes oxide in an ionic compound. In all of these, the oxygen has a -2 charge. We want to determine what the charge is on the chromium to make it electrically neutral. The first one, CrO, the chromium is going to have to be +2. So this is chromium 2 oxide. The next one, CrO2, got 2 oxygens, each worth -2. 2 times -2 is -4. So here the chromium, to make it be electrically neutral, has to be +4. So this is chromium 4 oxide. The next one, CrO3, each oxygen is worth -2. All told, they add up to -6. This is chromium 6 oxide. Even though you don't see a 6 anywhere in the formula, it's chromium 6 oxide because the 6 refers to the charge on the metal ion. W2Se5. W is tungsten. And selenium as an ion becomes selenide. We need the charge on the metal. Well, one little trick you can do when you've got like 2 or 3 or 2 or 5, something like that, and as the subscripts, you can just sort of cross multiply, switch around the subscripts to make it the charge for the other atom. So selenium 5 means the tungsten is going to be +5, and since we have a 2 after the tungsten, that means the selenium is going to be 2-. To make sure you can do your math, 5 times -2, all the seleniums add up to -10. Tungsten, 2 times +5, they'll add up to +10. Hence it's electrically neutral. So tungsten 5 selenide. You need to be able to write the name from the formula. You also need to be able to write the formula from the name. So manganese 5 sulfide. Manganese is Mn. Sulfide comes from sulfur, which is S. Sulfur is in group 6A. That means it gets a -2 charge. And so we can, since it's got a -2 charge, we're going to have 2 manganese. We're told the charge on the manganese is 5. That means the sulfur is going, there'll be 5 of those in the compound. So this is a similar type of formula to the tungsten selenide that we just saw. We can check it. Sulfur, 5 times -2 is -10. And for the manganese, 2 times +5 is +10. And hence they cancel out. Tantalum 3 fluoride. Tantalum is Ta. Fluoride comes from fluorine, which is F. We're told the charge on the tantalum is +3. What's the charge on fluoride? Fluoride is an halogen. When it makes an ion, it gets a -1 charge. So to make this electrically neutral, we need 3 fluorides, TaF3. Zirconium nitrate. Zirconium is Zr. It's in group 4, so we don't know what charge it would be, but we're told in this instance, since it has variable charges, that this one compound is +2. Nitride is the ionic form of nitrogen. It's got a -3 charge. Zirconium +2. So if we take and put 2 as a subscript for the nitrogen or nitride and 3 as a subscript for zirconium, that'll be the correct formula. We can check it. Nitride, 3 times -2 is -6. For zirconium, 3 +2 is the charge times 3 of those is +6. +6 -6 balances out, electrically neutral. Versus zirconium 4 nitride. Once this again, nitride is a -3, so we can do the old switcheroo trick. Put the 3 with the zirconium, 4 with the nitride, and that should balance it out. Nitrogen, 4 times the -3 is -12. Zirconium, 3 times +4 is +12. Now they're electrically neutral, and it cancels out.